Welcome to clickmyproject.com. Let's discuss about the product. Our product is a generative model for concurrent image retrieval and ROI segmentation. This paper proposes a probabilistic generative model that concurrently tackles the problem of image retrieval and region of interest segmentation, that is ROI segmentation. Especially, the proposed model takes into account several properties of the matching process between two objects in different images, namely objects undergoing a geometrical transformation, typical spatial locations of the region of interest, and visual similarity. In this manner, our approach improves the reliability of detected true matches between any pair of images. Furthermore, by taking advantages of the link to the ROI provided by the true matches, the proposed method is able to perform a suitable ROI segmentation. Finally, the proposed method is able to work when there is more than one ROI in the query image. Our experiments on two challenging image retrieval databases provides that our approach clearly outperforms the most prevalent approach for geometrically constrained matching and compares favorably to most of the state-of-art methods. Furthermore, the proposed technique concurrently provided very good segmentation of the ROI. Furthermore, the capability of the proposed method to take into account several objects of interest was not also tested on 3 experiments, 2 of them concerning image segmentation and object detection in multi-image object retrieved task and another concerning multi-view image retrieval. These experiments proved the ability of our approach to handle scenarios in which more than one object of interest is presented in the query. This paper considers the problem of large-scale query by example image retrieval. This problem has tradition and tackled using well-known bag-of-words model, a robust computationally affordable model that's also previously considerable thing. This model involves the generation of a visual vocabulary which allows for associating each local descriptor of an image with an visual word through a quantized process. As a result, each image can be described as a histogram of word occurred that is used to compute a similarity bit measure between every pair of images. This block diagram represents our system design. So this is the system design of our project. So in this, initially we are taking number of images as a database. That's the number of images should contain the same object but with different images and different scanneries. So our goal is to segment the ROI particularly and to retrieve the object. So initially the input image is taken, and for the ROI segmentation we proposed in this paper ANFIS segmentation. That means as one of the enhancement we are implementing ANFIS segmentation in the paper. So after the ANFIS segmentation we are obtaining the region of interest of the given image. From the given image we are obtaining that matching pixels. So the matching pixel is a database is retrieved and the matching property is compared with every image from the database. So finally from that the image is retrieved. Let's see the demonstration of our product. Our product is developed under MATLAB programming language. Hence, we are using MATLAB 2013A version. So, our program contains all these functions. So, this is the MATLAB main window. This is the current directory. Here, depend on the selected files, you can see the details here. This is the workspace. This will show the mat file temporary file descriptions here. This is the main command window. So here the file which we have to run is this file. So this file states, which is as we already discussed, initially we are using ANFIS segmentation to segment the ROI from the given image. Here we have used 2 databases. So initially I am going to segment the object from the given image by using ANFI segmentation. So I am running the program by using Fran, or you have to right click the program and you can select the run. So after you run the program .yum file, the program will open the database folder. From you have to select the image which you have to segment. So from the database 1 I am selecting an image. For example, I have chosen the image 1 as an input. So the input image is initially filtered by using filtering, because our given image is an RGB. So RGB image is filtered because every pixel contains the values and every noises also occurs as a values. For removal of that noises will make us better result. That's what we are doing, filtering. And then the process. Next process is process going on and uploading the process. The characteristic scale which represents the process level from bottom to up to the process completion. That process doing. So for segmentation, this is the selected seed points from the given image. You can see what are the seed points selected from the given image. So, and then it depends on the selected image, the ROI is marked by using fuzzy rules. We know what is the ANFI segmentation. That is a combination of neural network and fuzzy logic. So by using fuzzy logic and neural networks, we are segmenting the object from the given image. You can see the given image is marked by seed points and that is marked by the marker, and then finally that is segmented. So by segmented image we are masking the original image. So finally we are obtaining our original segmented image. This is the covered object by our process. So in the main command window we can see what is the ANFI process and what's the time it's taken for the process. So this all represents the ANFI's relevant information and the results, and the iteration counts up to 16 in this process. So we have segmented the image now. The next is our goal as our planned. We have to retrieve the corresponding object with the given image. So now I am running the next file, that is the image retrieval. Initially before that I was running plain file ROI.yum. .yum represents the MATLAB file. These other things are the sub call functions, and also we have used some inbuilt functions. So I am running this file. So we have to select the segmented image. So this is the image which I segmented previously. That will store in segmented images. So I am selecting the segmented image from the folder of segmented images. So I have opened the image. That means I have given that object to retrieve. So based on the given object, the image have to retrieve. So for the comparison, we are using shift and combination of surf and surf. That means shift and surf is called. Initially, we all know well-known shift descriptors and surf algorithms. In this, we have used a combination of shift and surf. That means shift descriptors and surf detectors. So because the combination provides the better retrieval accuracy than other retrieval algorithms. So you can see it's comparing with the overall images from the database. So it's denoting what are the process and what is the matching points is. So we can see what are the from 1 to up to, we have stored 12 images in the database. So for up to 12 images, that stores maximum possibility of images. So it is processing up to all images which is available in the database folder. So we have 15 images in the database folder, and it is processed with whole images, and the maximum matching points is related to this object because this is the actually retrieved image. So we can see what are the 15 images and matching points. So we can see what are the matching points. If that is a not relevant images, means that the matching points will not be more. So for relevant images only the matching point will be more. So for every images it is processing like that. So depends on the matching points, the maximum matching images will be displayed for us. So this is the maximum point matching. So the performance results, that is mean square error and PSNR values are displayed here, and the time elapsed for the retrieval is displayed as the results. Thank you.